So the properties of logarithms include the product property, which is if you are multiplying two values that you're taking the log of, so m and n, that's the same as saying log base b of m plus log base b of n. So kind of similar to how exponents work. If you're multiplying, it's the same as adding. Similarly, with division, if we were to divide m and n, that's the same as saying log base b of m minus log base b of n. So division is kind of like subtraction. But one of the different things is the power property. So if we were taking log base b of m to the n power, what happens is you will take that exponent and switch it to in front of your log, so it's multiplying by your log. So exponent is the same as multiplying, kind of just like how exponents work. So let's evaluate a couple of these logs. So it is going to give us an estimate for a couple different log base 4 values. So we are going to use those estimates and our properties of logarithms. So in the first one here, if I'm taking log base 4 of 3 over 7, that's the same as saying log base 4 of 3 minus log base 4 of 7. So the numerator minus the denominator. Okay, log base 4 of 3 is approximated at 0.792, and log base 4 of 7 is approximated at 1.404. Okay, so if I was to subtract these, I would get the approximation of negative 0.612. Okay, and that's just using the quotient property. Okay, with number 2 here, since I don't know what log base 4 of 21 equals, I could always split this up. So I know what 3 and 7 equal, so I'm going to split up 21 to be log base 4 of 3 times 7, because that equals 21. So remember, the product property of your logs, say that two numbers being multiplied is the same as adding. So I'm going to figure out what log base 4 of 3 plus log base 4 of 7 equals. So 3, 0.792, and 7 is, sorry, not 0, 1.404. And if I was to add those together, it would give me approximately 2.196. All right, final one here. In the case that I would have log base 4 of 49, since I know what 3 and 7 are, I know 49 is 3 times 3. Or sorry, 7 times 7. So I could break this up to be log base 4 of 7 times 7. And then I could use the product property. But since I want to use one of each, I'm going to rewrite 7 times 7 as 7 squared. So when you're taking the power property, your exponent can multiply in front of your logarithm. So that's the same as saying 2 times log base 4 of 7. Okay, log base 4 of 7 is 1.404. So this gives me 2 times 1.404, which will equal 2.808, approximately. All right, so that is all 3 of our properties shown in like a pretty simple example using approximations. And that is exactly what you are doing in the next couple here. So I'm going to skip ahead and look at some of our log expansions. So looking at this one here, you will expand logs using the properties of logarithms. So if I wanted to, I have a quotient property here. So I could rewrite this as log base 6 of my numerator, so 5x cubed, minus log base 6 of my denominator, which is just y. Okay, obviously y is a single term. There's not a lot I could do there, but I could still expand my first one because I have 5 times x to the third power. So I'm going to first of all expand those using the product property. So I could rewrite this as log base 6 of 5 plus log base 6 of x cubed minus log base 6 of 4. Okay, so now I have no quotients, no products, but taking a look here at my middle term, I do see that I still have an exponent. So I'm going to use my power property to expand that. So for my final answer, I'm going to have log base 6 of 5. For my product property, I'm going to move the 3 out in front. So plus 3 log of x minus log base 6 of 4. And that's going to be the most expanded form that I can rewrite that logarithm as. All right. So that is your expanding process. We have one more on the back side, but we will save that one for class. I am going to do one condensing problem. So let's take a look at number 1 here. So the first thing that I want to do is I'll go in the exact opposite order. So the first thing I'm going to look for is, do I have any power properties? Well, I see this 3 out in front, so I'm going to rewrite that as an exponent. So I've got log of 9 plus log of 2 to the third power, rewriting this as an exponent, minus log of 3. Okay, the next thing I'm going to do is I'm going to condense using my product property, which is when my logs are adding. So I could rewrite this middle portion as log of 9 times 2 to the third minus log of 3. So I do want to simplify what I have inside my parentheses here. I know 2 to the third is 8, so 9 times 8. I could really rewrite this as log of 72 minus log of 3. All right, so whenever I am subtracting my logs, that is my quotient property. So remember, the number you are subtracting, which is 72, is going to be my numerator. And the number you are subtracting from that is my denominator. So really, I could condense this expanded log form to be log of 72 over 3, which I'm actually just realizing I can divide 72 from 3. 72 divided by 3 is 24. So I could even write this one step further to be log of 24. And that's my simplest form. All right. So obviously we worked with a common log in that example. The same rules would apply to logs of bases and natural logs. The important aspect to remember is that they need to have the same base in order to condense or expand them. All right, we'll save the other examples for class if we need to go over them. So the last thing we're learning here is the change of base formula. So if a logarithm is not in base 10 or e, you can still use your calculator to evaluate them. So how you're going to do that is you are going to take your base and you are going to take the common log of that in the denominator, and then you are going to take the number you are taking the log of, and you're going to take the common log of that in your numerator. Same works with the natural log. Base goes in the denominator. The number you are taking the log of goes in the numerator. Okay? It doesn't matter whether you use the common log or the natural log. They both do the same exact thing. So let's take a look at this. So to show you that they both do the same thing, let's just do number 1 and we'll call it there. So I could rewrite this as, so I'll take what I'm taking the log of, and that becomes my numerator. So I'll take the common log of 35 over the common log of my base, which is 5. Okay? I could also rewrite this using natural logs. So I could take the natural log of 35 over the natural log of 5. Okay? So using a calculator, we are going to see real quickly that both of them will work and will give us our solution. There we go. Okay, so in my calculator, if I was to take log of 35 divided by log of 5, I'm going to get 2.209. If I was to take the natural log of 35 divided by the natural log of 5, I am also going to get 2.209. So although in my calculator, I couldn't originally evaluate log base 5 of 35, I can use the change of base formula to be able to still do so. All right, so I know that is a lot of different concepts in one lesson. Hopefully you were able to stick with me. Please attempt the problems we did not go through, and we will look at them together during class. All right, thanks for watching.